Ever wondered what the universe was like way back when? Like before the first stars, even. When it was basically a baby universe. Well, guess what?
Hmm.
Now we can actually get a glimpse of that. Today we're taking a deep dive into the James Webb Space Telescope, or JWST. And let me tell you, it's blowing everyone's minds.
It really is something else.
This isn't just your average telescope, it's more like a time machine. And we've got all the nerdy details from the JWST Wikipedia page to help us break it down.
It's a treasure trove of information, that's for sure.
So, what's the mission for today's deep dive? We're going to figure out what makes JWST so revolutionary. What can it see that, say, Hubble couldn't?
And why should anyone care?
Exactly, even if you haven't thought about space since you last saw a shooting star.
What's incredible about JWST, the thing that really sets it apart, is its ability to see light that's invisible to us. Infrared light.
Infrared. Okay, that sounds kind of familiar. So like night vision goggles.
That's a decent analogy, actually. You see, the light from the earliest stars and galaxies, it's been traveling for billions of years to reach us.
Makes sense. Space is big.
And over those massive distances, light gets stretched, shifted towards the infrared end of the spectrum. Scientists call it redshift.
So the older the light, the more redshifted it is.
You got it. And JWST, it's designed to pick up those faint, stretched-out signals.
So it's like a cosmic radio.
Exactly. And not only that, infrared light can cut through the dust clouds that block our view in other wavelengths. Think of it like having X-ray vision, but for space.
Wow, that's seriously cool.
Yeah.
So it's not just seeing farther, it's seeing clearly through all the universe's cosmic clutter.
Precisely.
Now, I know JWST is way out there orbiting the sun.
About 1 million miles from Earth, to be more precise.
Wow, 1,000,000 miles, that's a lot of miles. Why so far away? Couldn't it do its job a little closer to home?
It's all about location, location, location. See, JWST is parked at a special spot called the second Lagrange point, or L2 for short.
L2 rings a bell. It's like what do they call it? A gravitational sweet spot.
Right. Exactly. At L2, the gravitational forces of the Earth and Sun balance out, so JWST can just kind of hang out there without burning a ton of fuel.
Smart thinking. Saves on gas money, I guess. So it's like finding the perfect parking spot, but with a view of the entire universe.
Something like that, yes.
But why all the fuss about being cold?
Good point. To pick up those incredibly faint infrared signals, JWST needs to be super cold. We're talking negative 370 degrees Fahrenheit.
Brr, that's colder than my freezer when I've just restocked on ice cream. Why so chilly?
Any warmer, and its own infrared radiation would mess up the observations. It's like trying to hear a whisper at a rock concert. You need to block out the noise.
Makes sense. So distance isn't just about perspective. It's about keeping things frosty for those sensitive instruments. Speaking of which, there's been a lot of talk about JWST being, well, a lot more powerful than Hubble. Is that true?
It's true, but it's not like comparing apples to apples. It's more like comparing, let's say a magnifying glass to one of those high-powered microscopes they use in labs.
Okay, so a serious upgrade. But how so?
While Hubble mainly focused on visible and ultraviolet light, remember how we talked about infrared? That's JWST's specialty. It lets us see fainter objects, and even more importantly, it can peer much farther back in time. Think of it like this. If Hubble showed us the universe in its, teenage years, JWST is giving us a peek at the baby photos.
Okay, I love that analogy. We're talking about witnessing the universe practically still in diapers. This is amazing stuff. But how does JWST actually pull that off? What's the secret sauce?
Well, it's got this, not exactly a secret sauce, but a suite of super high-tech instruments on board.
I bet. Give us the highlights.
One of the most incredible ones is called the near-infrared spectrograph.
Try saying that 3 times fast.
NI-SPEC for short.
Much better. So what's so special about NR-SPEC? What's its claim to fame in the world of space telescopes?
Imagine, you know how detectives take fingerprints? NR-SPEC does something similar, but with distant stars and galaxies and stuff.
Hold on, cosmic fingerprinting. I'm intrigued. Tell me more.
It breaks down the light from these objects, like a prism making a rainbow. Each color tells us something different.
So we can actually figure out what those faraway objects are made of, like their chemical makeup and everything.
Exactly. Temperature, even how they're moving through space. It's like, having this super detailed cosmic map.
So cool. Like JWST is giving us the universe's biography, chapter and verse.
And get this, NIR-SPEC can observe, hundreds of these objects at the same time. It's all thanks to this mind-blowing technology called, wait for it, microshutters.
Microshutters. Okay, now you're just making up words. What in the world are microshutters?
Imagine a window, right? But this window's got thousands of tiny little shutters. Each one can open and close on its own.
Okay, I'm picturing it, kinda.
Each one is about as wide as a human hair, and they can block out light from certain areas.
So it's like giving NR-spec tunnel vision, helping it focus on one thing at a time, even when there's a whole lot going on.
You're getting it. It's like having hundreds of tiny little telescopes all working together at once.
That's some serious teamwork happening out there. Now, the Wikipedia page, it mentioned a few other instruments on board. What else is in JWST's toolkit?
Oh, yeah. There's NIR-CAM, which is short for Near-Infrared Camera.
Catchy name. What's that one do?
It's the main camera guy responsible for snapping those jaw-dropping pictures we've been seeing. And then there's NIRI, the mid-infrared instrument, which sees even deeper into the infrared than NIR-CAM.
So it's like NIR-CAM's superpowered cousin.
Pretty much. NIRI helps us peek through all that thick gas and dust, seeing things that normally would be totally hidden. It's especially good at studying how stars and planets are born.
So if NIR-CAM is capturing those gorgeous space landscapes, then NIRI is like the X-ray vision, revealing the hidden secrets of the universe.
You got it.
Amazing. What about, let's see, what was it called? FGS-NIRS. That one's a mouthful.
Ah, yes. The Fine Guidance Sensor and Near-Infrared Imager and Slitless Spectrograph. It's a team player, that one.
What does it do?
Two main things. First, it keeps JWST locked onto its target. You know, like a really, really steady hand.
So important. Don't want any blurry pictures.
Exactly. And second, it helps study exoplanets.
Exoplanets. Right. Those are planets orbiting other stars.
Yep. And JWST can actually study their atmospheres.
Seriously? How does it do that?
By analyzing the light that filters through the atmosphere, it can tell us what kind of gases are present.
No way. So we can actually tell what the air is like on a planet trillions of miles away. Is there, like, a weather channel for exoplanets in the works?
Haha, not yet. But seriously, this is huge. It helps us figure out if those planets could potentially support life as we know it.
Mind officially blown. This is incredible. So much to unpack here. But before we go too far down the rabbit hole of alien atmospheres, I want to circle back to something you mentioned earlier, starbirth. What's JWST revealing about those stellar nurseries?
It's giving us front row seats to star formation. Its infrared vision allows it to pierce through those massive gas and dust clouds where stars are born.
So we get to see baby stars being born right before our very eyes.
Essentially. We can see the clouds collapsing, gravity pulling everything together, and then bam! A star is born. It's a beautiful and powerful process.
Nature is incredible. It's amazing how each new discovery, it's like opening a door to even more mysteries.
That's the beauty of science, isn't it? There's always more to learn.
Speaking of mysteries, what about black holes? I know everyone's fascinated by them. What's JWST teaching us about these cosmic giants?
Black holes. They're like the ultimate puzzles, always keeping us guessing. JWST is giving us some seriously valuable data, especially about their role in the early universe.
The early universe. What's so special about black holes back then? Weren't they just doing their usual black hole thing?
We used to think they formed slowly over time, but JWST is showing us they were much more active in those early days. Way more active than we ever imagined.
Really? Like party animals of the early universe?
Something like that. For one thing, it's spotting supermassive black holes at the heart of galaxies that formed, well, really early on.
So these black holes, they grew up fast. Didn't waste any time getting big, did they?
Not at all. And that throws a bit of a wrench into our previous understanding of black holes. It means we might need to rethink how they form and evolve.
That's science for you. Always keeping us on our toes. So what else are these ancient black holes up to?
JWST is also shedding light on how they interact with all the stuff around them, you know, like gas and dust.
Right.
It's revealing those powerful jets of energy just blasting out into space. It's pretty wild stuff.
It's incredible how much we're still learning. Every time we think we have a grasp on things, the universe throws us a curveball. It's exciting, but also a bit humbling, wouldn't you say?
Definitely. It's a constant reminder that we're just scratching the surface.
Exactly. And with JWST, it feels like we've got this amazing backstage pass to the greatest show in the universe.
I like that.
So what else has JWST uncovered? We've only just dipped our toes into all the incredible discoveries. What else has got you excited?
One of the biggest things has to be the discovery of some of the earliest galaxies ever observed.
We're talking about galaxies that existed just a few 100 million years after the Big Bang, right? That's practically a blink of an eye in cosmic terms. What can you tell us about them?
They're like snapshots of the universe in its infancy, a time when everything was new, still forming. And what's really fascinating is, well, they're not exactly what we expected.
Oh, how so? What's got you puzzled about these early galaxies?
We always thought, based on everything we knew, that these early galaxies would be kind of, small, faint, like babies still figuring things out.
Makes sense. Young galaxies just starting to grow.
Right. But what we're seeing, it's kind of blowing our minds. They're bright, really bright, and big, way more massive than we ever imagined.
It's like instead of finding a sapling, you stumbled upon a full-grown redwood. That's a bit of a head-scratcher.
It definitely challenges our understanding of, well, pretty much everything we thought we knew about how galaxies form and evolve. It suggests that maybe, just maybe, the early universe was a much more happening place than we thought.
A cosmic party billions of years ago. I like it. So while we're looking back in time, we're also rewriting the history books. Pretty cool job, if you ask me.
It really is incredible, and it makes you wonder what else is out there. What other surprises are just waiting to be discovered?
That's the beauty of it all, isn't it? The universe is full of mysteries, just waiting for us to uncover them. And with tools like JWST, well, it feels like we're just getting started.
Exactly. Every new observation, it's like opening a new door, leading to even more questions, more possibilities. It's a reminder that we're a part of something so much bigger than ourselves.
It's humbling, for sure, but also incredibly inspiring. It makes you want to keep asking those questions, keep exploring, keep pushing the boundaries of what we know.
Couldn't have said it better myself. The universe is a vast and wondrous place, full of secrets waiting to be revealed. And with JWST as our guide, who knows what incredible discoveries await us in the years to come.
Exactly. Maybe we'll find evidence of life beyond Earth or unlock the secrets of dark matter and dark energy. Or maybe, just maybe, we'll stumble upon something so unexpected, so mind-bogglingly strange, that it completely changes our understanding of the universe once again. The possibilities are truly endless.
And that's what makes it such an exciting time to be stargazing, even if we're doing it with a telescope that's a million miles away.
That's a great way to put it. Well, there you have it, folks. A deep dive into the incredible world of the James Webb Space Telescope. It's a story of human ingenuity, groundbreaking science, and the never-ending quest to understand our place in the cosmos.
It's been quite a journey.
It really has. So next time you gaze up at the night sky, remember that out there, amongst those twinkling stars, a time machine is hard at work, revealing the secrets of the universe's past and hinting at the infinite possibilities of its future.